Lesson 2 is all about angles, polygons, triangles, and quadrilaterals. In this lesson we're reviewing some of the terms we've discussed in previous textbooks. Now, a right angle. If we talk about a right angle, we're talking about an angle that's 90 degrees. Now, we've got this neat tool over here that's a shape recognition tool. Let's go ahead and use that and see what happens. So a right angle is a 90-degree angle. Okay, so we've got a 90-degree angle right there. An acute angle. An acute angle is less than 90 degrees. So here we have an example of an acute angle. In your notes you can just draw out the pictures just as I'm doing in the video. Now an obtuse angle is greater than 90 but less than 180 degrees, so our angle would be right in here. And a straight angle is just a straight line. So our angle would be right in there. Let's see what happens. Made it into a little interesting degree or symbol. Now let's go ahead and move on. Hopefully that was review for you. Now if we're going to look at a polygon is a closed two-dimensional figure with straight lines. We can say 2D for two-dimensional figure. Now a polygon could be like a square. Okay? A polygon could be a triangle, or it could be a 6-sided figure or an 8-sided figure or a 120-sided figure, as long as it has straight lines. Let's go ahead and make a figure that looks like this. Okay, and that went into a circle. A circle is not a polygon. Nope, this is not a polygon because it does not have straight lines. So this one is a good example of something that's closed and two-dimensional, but it's not a polygon because its lines are not straight. Okay, if we want to classify polygons, I've made a table here, a quick table before the video started. If we have a 3-sided polygon, that would be a triangle. A 4-sided polygon is called a quadrilateral. Make sure this gets into your notes as well. A 5-sided polygon is called a pentagon. 6-side is called a hexagon. 7-side is a heptagon. 8-side, that's like a stop sign, that's an octagon. 9 sides is a nonagon. 10 sides is a decagon, D-E-C-A-G-O-N. 11 sides is an undecagon, U-N, decagon. And 12-sided is a dodecagon. Now we typically stop here with our names, because once we have n sides, we call it an n-gon. So, for example, if we had a 120-sided polygon, it would be called a 120-gon. Okay, and you could write out 120 if you wanted to. We'll just use the letters here, or the numbers here, 120-gon. And that's how we can classify polygons by their number of sides. Please pause this video now if you need more time to write these names down. Okay, more ways we can classify polygons are if they're concave or convex, and if they're regular. So a concave polygon will always have a cave somewhere in it. And that cave, it's easy to see because if we take 2 points on the opposite sides of the cave, our straight segment through them goes outside of our polygon. So it's going to look something like this. Now a convex polygon is just the opposite. If we have a convex polygon, it has no cave. Okay, so convex, if we take 2 points, we can never get a segment between those 2 points to fall outside of our straight lines within our polygon. So that's the difference between concave and convex. Now a regular polygon. An example of a regular polygon would be a square. Okay, that's the simplest of them. A regular polygon will always have side lengths that are equal. 1 tick mark all the way around means the side lengths are equal. And its angle measurements are always going to be equal. So angles here must be 90 degrees. Okay, so the side lengths all have to be the same. If we look at our shape tool, we can see we've got an equilateral triangle here. And an equilateral triangle is another example of a regular polygon because the sides are all the same length. and the angles are all the same measure. Okay, now when we move on to triangles, we've got several different types of triangles. Our first one is a right triangle, and a right triangle has one 90-degree angle. So it's going to look something like this. Again, pictures work very well to show each of these definitions. An acute triangle. An acute triangle could be like our equilateral triangle. So we'll take our equilateral triangle. If it's equilateral, it must be same side lengths, and it must all be the same measurement of our angles. Okay, so each angle here we can see is less than 90 degrees. Each one must be acute. An obtuse triangle. If we have an obtuse triangle, it means we have one angle in our triangle that is greater than, now that didn't turn out to be a triangle because it made it into a fourth line there. 1, 2, and 3. Let's see if that comes out straight. Yeah, it does. That's obtuse because it has one angle that's bigger than 90 degrees but less than 180. Now equiangular, if we talk about an equiangular triangle just means all the angles are the same. So if all the angles are the same, we can show that by saying one tick mark within each of our angle measurements. Okay, it means all the angles must be exactly the same. Hopefully this is a bit of review for you. Okay, we've got a triangle here. This must be an obtuse triangle because it has one obtuse angle, and we need to find x. Now the thing that we need to remember about triangles is the angles always equal 180 degrees when we add them up. So the sum of the angles equals 180 degrees. So if we know that our obtuse angle is 130 degrees, one of our acute angles is 30 degrees, we add those together, we get 160 degrees, and subtract that from 180, we can find out what x must be. X must be equal to 20 degrees. And we have our final answer. X is equal to 20 degrees. We know that's true because the sum of the angles in a triangle always equal 180 degrees. That's a key part of knowing, a key thing to know whenever we work with triangles. Alright, now we want to find x and y. In this problem we're given these tick marks. The tick marks mean that these two sides are the same length. So if these two sides are the same length, it means the angles opposite them must be the same measure. So if the angle opposite our first side is 50, the angle opposite our next side must also be equal to 50. We'll put in our degrees symbol. So if x is 50, and this is 50, that's a total of 100 degrees. We're going to subtract that from 180 degrees to get a grand total of 80 degrees left over. So y must be equal to 80 degrees. That's our only choice for this problem, given these numbers. Okay, types of quadrilaterals. This is the last part of our lesson for today. The first type of quadrilateral we have is a parallelogram. And if we look at our shapes, we can find a parallelogram in here, right there. Parallelogram will just have two pairs of parallel sides. A trapezoid. If we look for a trapezoid, we can find it right here. A trapezoid has one pair of parallel sides and the others are not. A rectangle. If we look for a rectangle, here we've got a long thin rectangle. A rhombus. We do not have a rhombus in our shapes. Let's use our writing recognition tool. A rhombus is like a square, except for the fact that it might not have 90-degree angles. Okay, so a rhombus is like a square that's been pushed to the side. And then finally we have our square, and our square, well, square of course just looks like this, and it's got all sides equal length, and it's got all angles of 90 degrees. We're going to continue talking about these definitions in our lesson practice on page 8. Make sure you've got your notes completed, and I'll see you during our next class.